everyone. Thank you very much for inviting me here. Thank you, Ima, for organizing this. I'm Andrey. Today we'll be talking about Kotlin, and I would like this to be more of a conversation than a lecture. So your questions are very welcome at any point. And my overall goals with this kind of talk, when I'm talking about history of how we developed Kotlin, is to reflect on my own experience. So I like to think back to things that happened many years ago, share some interesting stories of some of those. We'll gauge as we go which ones are entertaining for you, and of course learn more about what you're interested in to make my talks better. So a few disclaimers. I'm not affiliated with Kotlin anymore, so everything I'm saying is a lie. Yeah, and of course I can misremember things. Okay, so this talk was initially put together as a sort of assortment of anecdotes from the past. And I will not do it as a sequential thing. We can pick one and go with it. So if someone has a favorite among these things on the screen, you can point me to that and I'll start with that. Any preferences? All right. All right, that's a happy story. So an important bit of context is that Kotlin was initially not conceived with Android in mind. We started Kotlin back in 2010, and Android wasn't very big then, so didn't consider it a big target platform. So our timeline in general sounds like this, where we started discussions in 2010, and it was like very preliminary work during 2010 and early 2011. Then we're ready to announce the language in 2011 and plan the beta by the end of the year, basically, which never happened. And next year, and the next year, and the next year, we only released in 2016, which, yeah, some of the reasons for that I'll tell you about later. And Android happened even later than that. So official support we only got in 2017. So some context for this would be that actually, yeah, we had like no consideration for Android at all as we were putting together the initial design. 2011, Android wasn't on the table. It was only somewhere in 2012 when somebody else outside of JetBrains mentioned Android to us. Not like we never heard about it, we never thought it was relevant. So many years later, things changed and we got serious about Android. And for a while, we were actually trying to pester Google in different ways to get some official support because our users wanted it. And it didn't happen instantly, but it did happen. And I would like to open with the reasons I think Google made this move, because it's a big move. For a company of this size, it's a huge liability to have official support for technology provided by somebody else, not them. And of course, they wanted that to be different, and they tried to buy JetBrains upfront. Like as soon as the talks about Kotlin started, first thing on the table was, let's just acquire JetBrains. But the company is in private hands and it's not for sale. So we had to work out a different solution for that. So like, why was Android as a community and as a platform so desperate for a new language? So basically, the context for Java in general would be relevant here. I actually have a slide for that, but it's in a different deck. But I'll just describe it orally. So Java was very big by the late 90s, and things were rosy, and 2004 was a big release of Java 5, where generic classes came along and many other good things came along. And it was all very bright, but it turned out that the dot-com crash more or less killed Sun Microsystems that made Java. And the next meaningful version was Java 8 in 2014. So between 2004 and 2014, Java didn't progress very much. It was a big problem for the community because, first of all, everybody felt that like nothing was happening in the language, and also over the fence in the C# world, in other worlds, things were much brighter. C# had all the nice things, and ran on a completely incompatible platform that nobody could use in the Java world. It was very frustrating for a lot of people because if you like JetBrains, for example, we were in the same situation. JetBrains had like about 15 million lines of code in Java. And it really hurt to be writing that same language from early 2000s in 2010 with no hope for progress. So it was a big pain. But Android was even more stuck with old Java because even when Java 8 came out and was a big update with lambdas and other important things, Android still had a virtual machine deployed to every device. 4 billion devices, 4 billion old versions of the virtual machine in people's hands. And it's not trivial to update that. Like, I think, well, at least 2 or 3 years ago, updating a virtual machine was still a major operation system update for the phone. It was in the works then to actually start updating the runtime without redoing the whole operating system core. So it was a big deal. And so the way Java moves forward is basically by bumping the version, not only in the language, in the syntax, but also in the virtual machine. It means that newer features in the language mean newer features in the bytecode, and that bytecode needs to be run by a new virtual machine. It was always a problem. And with more and more progress on the Java side, it was a bigger and bigger problem. So another problem, of course, was that Google, I think, is still being sued by Oracle for $9 billion for using Java in Android without permission. And that's like, this is from the legal standpoint, a very interesting lawsuit about like what can and cannot be copyrighted and what an idea means and so on and so forth. That's all very, very bright and interesting, but the entire Android division is under litigation. Like their emails can be requested to court anytime. So if you're collaborating with someone in Android and they want to have a call in an hour, it means there's something that doesn't go into email. Yeah, so this is the kind of thing that was the basic backdrop. There was also a very obvious realization that Apple, the main competitor, had Swift for their developers. And although Swift wasn't very widely adopted yet, it was very clear that there's a better language on the other side. The other side has all the shiny good things, everybody's talking about it, and we're stuck with Java. And Java in our world doesn't progress even as much as it progresses for the server side, for example. So it was a very big problem for the Android community. And also, there was this very interesting situation where from inside Google, the Android division also was experiencing quite a bit of pressure from the Flutter team. So there is this interesting line of the Dart programming language. So somehow, people who like to write languages in virtual machines never stop. So people who many years ago did the initial version of the Hotspot VM wanted to do something else and finally did Dart. Dart is a very updated version of their sort of managed language vision. Was done at Google, didn't really fly on the first try, but it didn't give it up. And finally, it found a very interesting application in a very interesting context. So Dart and Flutter are currently hosted by Google's AdWords division, which means they have all the money. So yeah, and basically the Dart language became a very good platform for a UI framework called Flutter, which provides incredibly good development experience, and the Dart virtual machine helps greatly with that. They have incredible hot swap on the device. It's very easy to change your code and see the changes on the phone very, very quickly. It's also cross-platform, so you can target Android and iOS. So it was incredibly hyped by the development community because it was just, the bright future every developer wanted. And on the other side, but this is, again, a different language, different virtual machine. It's not really compatible with anything Android. I mean, there are compatibility modes, but it's not like you can seamlessly integrate the two things. So the Android division was in this position where nobody's happy with the Android development experience on many levels, like it's very slow, Java is very old, the library APIs are not great, and there is this shiny bright thing coming out of Google, and people keep asking like, okay, but when are we getting that on Android finally? Like it's Google making it, right? So when is this happening? And their Android division is like, okay, they're under a different vice president. We don't have anything in common with these people, and we absolutely aren't adopting that for our platform for real, because like, again, 4 billion devices, how do you even do that? And like, it was never a plan to adopt that or Go, for example, for Android because of incompatibility with the existing technology. So that was like a very uncomfortable position for the Android division, of course. And also on the bright side, there was Android Studio, which is the IDE everybody uses for Android. It's built on the IntelliJ platform from JetBrains. It's an open source platform that's been used by Google for, I think, since 2015 or something, or was it 2014 was the release date. Yeah, and it was already an established relationship. So at some point, what actually happened was the Android people were, they commence regularly this, what they call a advisory board, when they basically invite like people from big companies using Android to engineers to talk about what's important for the platform, how they see the development of the platform, so on and so forth. And that board, just basically one of the things they do, they rank the issues they see with the platform in prioritized order. That's it. And in the year 2017, or like late 2016, I don't remember, the top one issue on this list was, give us a new language, please. We're tired. Right, and this is sort of the backdrop for this decision. So there was this situation plus that input, and inside Google, very brave people decided to persuade the management to actually take this risk and engage with a much smaller company that doesn't want to be acquired and makes this shiny language everybody wants. This is how it happens. Any questions about this? All right, so yeah.
Does Google ever actually, they are being sued currently by what's the Oracle? So is that one of these things that's going to go on and on forever?
Well, yeah. So the question is, this lawsuit between Oracle and Google, is it just going to go on and on forever? I'm not a lawyer, but I would imagine this is what Google wants at this point. I mean, it may be their best strategy, because I think it went to very high courts and back and forth. And the rulings are very interesting to read as sort of educational material on copyright and everything. So I think the main point of contention is whether an API can be copyrighted. So whether an API is an idea or an expression of the idea. So that's a very interesting philosophical question. And yeah, well, I have no idea. I don't even know if there were new rulings. I didn't check recently, but I think it would be in the news. Yeah. So this is the main reason why this whole thing happened. And of course, like how it actually was structured was a couple of months before the big Google I/O conference in, I think it was late March or April, no, late March, I think, 2017. I was on vacation, and the day I left for my vacation, I got an email that some people from Google want to talk to us. And my first morning in my hotel in Paris, I'm opening my laptop, connecting to the meeting, and hear that, yeah, we decided we might want to consider official support for Kotlin, and announcing it at Google I/O in 2.5 months from now. We're like, wow, cool. This is what we wanted. What do we need to do? And yeah, and there was this like technical side where like what kind of technical requirements we have, but also there was like a very obvious statement of legal side where like, okay, so we already had a problem with something around languages provided by third parties. So we really don't want to end up in that situation again. And let's work out something that actually guarantees that that doesn't happen. So it was like, I mean, it's a sensible wish on the big company side. Like everybody wants to sue them. It's very understandable. So this is basically the beginning of how the Kotlin Foundation came about. And we arrived at this design fairly quickly. And the idea was there is a nonprofit corporation which owns the trademark for Kotlin. And the code is open source anyway. Nobody cares who owns that. Like it's under a free license. It's Apache 2. There's no contention about that. So trademark is the only thing. And this foundation will be managed jointly by JetBrains and Google. So this is a absolutely sensible, easy to describe idea, but then it comes with like loads of paperwork. And there's no way you set up a nonprofit in the US in 2 months. It doesn't happen. So we needed like to announce anything. We needed to work out something that will work while this foundation is being set up. So we basically put together this kind of agreement where we both promised to create this foundation and to move the trademark there and to cover Google's risks for that period of time. JetBrains transferred the Kotlin trademark to Google under this contract, and they had an obligation to transfer it back to the Kotlin Foundation. So and this is why you can see that in the history of the Kotlin trademark, there is a record about Google owning Kotlin for about 1 year. Yeah, it's a technicality. Google never made Kotlin or owned Kotlin as such, but they kept the trademark for a year because we needed to mitigate the legal risks. Right, so, and those like 2.5 months were quite intense in terms of technical work, but also in terms of legal stuff. And again, I'm not a lawyer. I didn't know anything about legal, but when I'm offered to read a document that says, like, here are the rules for voting on the board. And the board has like 5 directors, and like this kind of question requires majority, and this kind of question requires supermajority of like 75% or something. So what I do at this point is I ask my friend and colleague, who's like very smart, to just sit down with me and do a whiteboard testing for this kind of scheme, because we did find bugs in that. And like, it's a complicated algorithm. And of course, every time it's changed, you have to rerun everything manually on a whiteboard again. I think we did at least 3 rounds. And on the first 2, we found some issues. So it was very entertaining. Absolutely not what I was thinking about when I wanted to become a programmer, but you know, it's also dealing with code written in very boring English. Yeah, so it was very entertaining. And finally, there was a big celebration, Google I/O 17. There was this like, huge ovation when they announced this, and I was there in the room. It was very, very heartwarming. Actually, great. We were all like really overworked by that time. It was very nice. Any questions up to this point? Go ahead.
Yes, it took about 5 years to actually develop the language to the point where you could release it up to the market.
Yes. Okay, so is there a question? So it was a statement.
Well, why would it take them?
Okay, the question is why it took us so long to develop the first version. I'll go back to this. I have a separate sequence of slides about that. So just wait a little. All right. So just a quick overview of what happened after the adoption moment. So our user base shot up very quickly. We had 1 million users by the end of I think by middle of 2018, and then by now it's around 5 and something million people who do something with Kotlin in a year. So this kind of thing wasn't anything I personally expected. Yeah, go ahead.
So how did you measure that?
Okay, that's a very interesting technical question. So basically, we cannot measure, of course, we can't measure people, like how many people compile Kotlin, for example. We cannot measure, basically, like we can measure downloads of libraries, but they are not relevant, so on and so forth. There are build servers and everything. What we can measure, though, is how many people use a Kotlin editor in an IDE. And of course, we don't own all the IDEs that are used for Kotlin because a big part of that is used by Android, owned by Android. So what we did is we noticed that the Kotlin plugin requests a list of possible updates for itself. And what we measure, so basically how it works, we try to not bother users with updates when they're not using Kotlin. So we see when somebody used Kotlin today, like opened the Kotlin in the editor and did some edits. Then we request an update, and the server just logs those requests because it has to have an ID, like identification for the ID, because otherwise the updates will not be tailored to it. So this is what we measure. So it's people who edited Kotlin code in a Kotlin IDE on the JetBrains platform. So maybe a little more people, but very unlikely. More questions?
So this is just on JetBrains and just
so it is on a JetBrains platform, which is both IntelliJ IDEA and Android Studio.
so they don't
Yeah, so if anybody does that, I don't know, on GitHub or in VS Code, we don't see that. Yeah. Okay. Yeah, so another thing is we didn't plan for it, and how it all started for the Kotlin team before all the Google thing was this question we got in the forum, which was basically, does Kotlin work in Android? And I was like, well, it should. I heard that Android uses Java. Kotlin should work. We use the same bytecodes, don't we? Yeah, so basically what we got was a bug report with like, yeah, I did try it and it doesn't work. And this is how it fails. And this is a wrong answer from me. Like this Stack Overflow thing doesn't solve anything. So basically what we found out with this thing, initially we got a segmentation folder, of course, and like this error basically means that the people who did the Android translator from the Java bytecodes to Android bytecodes, those people actually read the spec. Because the people who did the hotspot couldn't read the spec, because the spec was written after the hotspot was written. And when we ran everything on the hotspot VM, it was not complaining, it was working fine. But when we ran on a different platform that actually adhered to the spec, the platform said, oh, you're putting weird flags in your classes. You're not supposed to do that. We were like, okay, thanks, Android. We'll now run everything. All the code we generate will always run for Android because it is a very good QA engineer. And this is what we're doing to this day. So we run our code through, I think, through Dex and through the Android runtime verifier because they are more attentive to the spec than the official VM. And yeah, and we had lots of issues with those flags. Like this one is a very weird thing from like Java 1.1 or something. Nobody cares, of course, in the modern world, but the spec says it has to be there. And this one was pretty annoying because we had a weird behavior that basically our virtual methods weren't working properly. We're like, what? Like, what's wrong with Android? How aren't those working? And what all we got was like their runtime, basically. And we were already like gearing up to debug the runtime, like, and try to figure out how it works. But somebody Googled the same issue and found it on the Groovy issue tracker. People over at Groovy fixed that already, had an explanation for us what we needed to do. And we just did it. It was very nice. Like open source is great. Yeah. Another thing we had, which is something you start getting when you venture into system software, more or less, which is like Kotlin is not system software for real. Like it's a mile between us and the metal, but still, like we get segmentation faults from virtual machines sometimes. So this one is not actually related to Android. It's just a funny thing to tell you. So the thing is, in the early versions of Kotlin, the compiler just wasn't smart enough. It was buggy. And when it saw that we are calling the set method on an array directly and not through a convention of square brackets, it just emitted a call to a set method on an array, which is not a thing in Java. Java arrays are special. They don't have this kind of method. But it turns out if you, on this version of the virtual machine, if you try to call a method that does not exist, the virtual machine segfaults because an array is a special class. It doesn't have a virtual table at all. And it just, goes into corrupt memory, and that's it. Yeah, so this was a funny thing. Like, box ticked, I broke a virtual machine today. All right, yeah, so basically after all this, figuring out how to actually run on Android and dealing with their tool chain and everything, by around 2014, we dedicated quite a lot of attention to Android because it was basically the idea was by that time that probably if people write mobile applications, they start many projects from scratch. It's a new field. There are many new projects. There are many smaller projects. And it's much easier to start a project from scratch in a new language than to migrate from an existing language. So we were targeting Android pretty deliberately since 2014, on par with the server side. And this is why we worked pretty well on Android by the release time. Any questions about the Android story? Go ahead.
What was it initially directed at before it? Yeah.
Good question. Thank you very much. So the question is, what kind of people did we target before Android came along? So the initial idea was to target Java developers. And back in 2010, Java developers meant mostly server-side people. It's all kinds of enterprise applications, websites, whatever. And there were two big desktop applications in the world, IntelliJ IDEA and Eclipse. And well, desktop development was a thing in terms of users, but it was not a thing in terms of developers. So it was basically only server-side. Applets have already died out. Yeah, they had died out by that time. So yeah, it was just server-side. No questions. All right. Yeah, go ahead.
How many of you were the team?
Oh, I have a graph for that. Let's go and see it here. So this is the team size. Unfortunately, yeah, this panel obscures the years, but this is 2010, 11, 12, so on. Right, so we started back in 2010 when I joined JetBrains to start Kotlin. We had two people part-time, myself and the former CEO of JetBrains, Max Shafir. We're together, we're discussing the design, basically. Started working in the compiler with another two part-time developers. And by the release time, I had about 30-something people.
The traditional problem behind you is making any money from it, and it's open source.
Right.
How did you plan to make money from those people?
Okay. So that's an interesting thing. So just to set the stage here. People don't make money off languages. You're absolutely right. And like the age of selling a language commercially, it's ended, I think, by the mid-90s, more or less. So we were very late to that table.
Microphone is still making a lot of money as well.
Oh yeah, well, yes. If you want to do COBOL is all about money. You're right. Yeah, so I'll give you a little bit of context and explain how the reasoning went there. So basically, most companies that make new languages make them for a platform or just because they can. And for JetBrains, it was kind of in the middle. Well, because we didn't own a platform, and we kind of could, but we weren't as rich as a big company. But still, so 2010, at the time when I joined, JetBrains was about, I think, 300 people. And the products of the company were IDEs, the major IDEs for Java and C# were drawing in a lot of money. And also there were pretty popular Ruby, JavaScript, Python, and other languages. So it was all IDEs. Also, there were team tools. TeamCity was a pretty popular integration server that eventually made quite a bit of money. So that bug tracker and a little bit of research with MPS, a very interesting domain-specific language workbench. And the idea in the company was that we as engineers know better, and the company was run by engineers. You know, it's kind of a like dream kind of company for a person who wants to write code. Everybody wrote code, the CEO wrote code, you know, was this kind of super engineering culture. And so this kind of company absolutely ran on dog fooding. So the idea was, like, our slogan is develop with pleasure. A productive developer is a happy developer. We were making jokes of like optimizing the curvature of developers' smiles. And like the more productive we make people, the better it is. And the basic premise was what's good for us is good for all developers. If we make a tool we enjoy ourselves, everybody will be happy. And we established direct communication between users and people who wrote the features they use. So if you had any problem or any question about JetBrains product, you wrote to a forum or to the issue tracker and got responses from developers who were responsible for that code. This is the backdrop. And basically, at this point, we did all the IDs for popular languages that were available, more or less. And the question was, like, what else this company can do for developers? What kind of product will help developers even more? And one of the ideas was a new programming language, because look, we are struggling with Java here. What's good for us is good for everybody. So let's fix the Java problem somehow. And folks over JetBrains looked at existing alternatives, looked at Groovy, looked at Scala. Neither was a very good fit for this kind of huge code base. So the idea was, let's maybe tackle a new language. And as I described, by 2010, Java was in very bad shape. So the basic sense was that you can't fix Java because it's too difficult, too much legacy, and like the tradition is making the team very slow. It's not going to progress very much. And it was basically a window of opportunity for the company where we had stagnation on the one side, a lot of frustration. Groovy and Scala weren't really fitting the bill. And we're kind of in a good position because a lot of developers know us. So we may be able to put a new language in the market. So directly answering your question, the reasoning was that JetBrains as a company wants to become a trendsetter, not a trend follower. What we used to do before was, okay, there's a language that has a lot of users, let's make an IDE for it and sell it to that group of users. And that's all right, but you have to chase the target all the time, right? So whatever somebody does with that language affects your market. And here you can have your own market. So the three reasons that were officially listed, and it was exactly the same internally, was we want to boost our own productivity because this is how we work. Our productivity is everybody's productivity. And for productivity, we needed like a modern language, of course, which is like much more advanced than Java, but also good tooling because we're a tooling company. This is how we work. Good interoperability with Java because we have 50 million lines of code here. We have to do something with that. And good compilation speed because this was one of the major issues with Scala. Scala didn't really fit the bill because it was a very slow compiler. Yeah, and later on, we had a lot of trouble actually fitting into this requirement. So that was one thing. Another thing was directly driving sales of IntelliJ IDEA, the main product, because having your own market makes a lot of sense. And that turned out to be a pretty slow uptake process because a lot of users are on the Android Studio side and aren't paying. So, but still, the server-side users are paying, and there are quite many. I think maybe near 1 million at the moment. I don't really know the numbers. It was about 300,000 in 2020. And also, a very important thing is just drawing attention to the brand of the company. because it was very well understood that programming languages is something people fight about a lot. And, and this is how you make good ads online, right? Say something about a programming language and you have like 1,000 comments about how other languages are better or whatever. And it was a very deliberate thing, like a programming language is something everybody will be talking about, and we want to be at the center of that discussion. And also JetBrains was insanely profitable, so we could afford supporting this kind of team. It cost quite a bit of money, but it worked out. Okay, so is it answering your question? Yeah, thank you very much. More questions? Okay, I have your question on the stack, so I'll go back to that. And that was what took us so long. So what took us so long from 2010 to 2016, early 2016, it was over 5 years that we're working on this language, which is terribly long. And if I had to do it again, I would definitely release much sooner, but I didn't know how to do that when I was 26. Yeah, so a few reasons why you shouldn't create a programming language. The whole thing is centered around the illusion that a language is a mathematical object. Mathematically it is. Practically, it absolutely isn't, and it isn't a compiler, unfortunately. So the language design thing was what we focused on initially, because everything else seemed like a technical problem. And this is like an invention thing. And language design was hard to get right. Like it took us a while to actually figure out all the interactions between different features, especially the interoperability thing. The Java interop took us multiple iterations. And in terms of like technical challenges, this was, I think, number one thing that slowed us down. So reason number one why we released so late was we tried one approach to Java interop, it didn't work out. We tried another one, it didn't work out either. Then we talked to some people in academia. They proposed something. We were very excited about that. We had to completely reshape that to implement it in a like real setting. Only then it more or less came together. So it took us, I think, like 2 years or something to figure that out. So that was a major drawback. But also figuring out all the ecosystem, because the implementation requires a compiler, requires libraries, of course, and docs and the build system and the package management and the IDE store, and debugger is such a pain. I'm fascinated by debuggers, but I also hate them because it's like implementing a debugger in a language that has inlining or anything actually, like any syntactic sugar. This is incredibly difficult. Also, like the biggest thing with all the tools was interop, basically, I think any experienced engineer understands this. If anybody ever offers you to interface with a complex system and on a very intimate level, you should ask for a lot of money. Because like the Java interface surface for us was huge. It was, of course, the bytecode and the libraries and the logic of the Java compiler, but also it was every tool we were using, because the build system has to be compatible with Java and Kotlin to make them work together. The package management should be compatible. The IDE should be compatible. The debugger runs on the Java runtime. Even the documentation tool that produces those HTML files has to be compatible with Java, because people will be developing mixed projects where Kotlin and Java files sit next to each other. We didn't anticipate that much complexity. We understood it was a challenge, but not that much. So on the technical side, this was the issue. There's a lot of integration, a lot of it is fragile. Every update requires some tweaks on our side, so on and so forth. But also, another issue was in 2010, I was 26. I had zero experience managing people. And I thought I knew everything. And that's a recipe for a very interesting adventure, which it definitely was. So basically, also like the company was growing and adapting to its own growth. So there wasn't huge management expertise in the company either. So I didn't have like a mentor who could sort of tell me that I was doing things suboptimally. Yeah, but in any case, it was quite a big challenge to manage the team, and many things didn't work out very well there. So I'll just skip to, oh, can I? No, I can't skip to that because my slides are missing that. I'll just show you that graph again, sorry. Where's that? Here. So basically what I did here, of course, no management was required. It doesn't matter. You're basically working on the whiteboard, it's okay. 4 people, no management required. We were like all writing code. 2 people were writing the back end. I was writing the front end, and Max was doing the integration and the ID and the bits here and there. By this time, 15 people is already not very comfortable, but I can run fast enough to micromanage 15 people. So I didn't notice there was a problem by this point. And by this point, I managed to run around fast enough to micromanage 30 something people, but I couldn't do anything else. So this is the point where I stopped writing code. I couldn't do anything but talking to people at this point. And it's a complete trap because nothing works without me. And I have 0 spare time to change the system so it can work without me a little more, and I have some spare time to do some other things. It was a complete trap, and I struggled through this whole thing to figure it out and make it like a normally managed team. So of course, this slowed us down quite a bit because I wasn't as productive, because the team wasn't getting up to speed as fast as it could. That was another reason. And also there was the inconfidence part, like which is a kind of a paradoxical thing. Personally, I wasn't an overconfident man at that time. Like I thought I knew everything, I could do everything, but I kind of hesitated to come up to other people at JetBrains who were more experienced in making tooling, for example, and invite them to work on Kotlin. Because I thought it was distracting resources from projects that are actually making money to this experiment we are running here, which I don't know if it's going to work out, and is it even okay to, try to attract people to this project. It was absolutely okay. And I think somebody even told me it was okay, but I still felt I couldn't. And so I was growing the team very, very slowly in terms of experienced engineers who knew what they were doing. And we were we got some very good people. But with my teaching background, before Kotlin, I was doing a lot of teaching at the university. And I really knew very well how to spot a good student, how to work with students. So we hired a lot of interns, and they are very bright people, and they're currently already incredible engineers, but it took them a while to ramp up. And they were the actual force in the Kotlin team, which was a big mistake. Nobody pointed out to me at the time. Which, I mean, maybe they just realized I wouldn't have listened. So this is the reason number 3. So basically, to sum it up, what took us so long, to sum it up, it was A, just the complexity of the thing, B, lack of management skills, and C, this lack of timing for hiring experienced compiler engineers on the team. But also, there was the issue of backward compatibility. Because that, what I know now, which I didn't understand then, is that it's okay to release a language, have 1,000 people use it, and then release the next version breaking backward compatibility. It was, at the time, I thought when you release, you have to 100% maintain compatibility from that point on. And it felt like a big responsibility, and we had to figure out everything, get the main things right at least, before we release 1.0. And I mean, it was motivated, it wasn't just a religion. A lot of people were complaining about this problem in the Scala world at the time. And the Scala situation was like actually very uncomfortable because Scala was breaking binary compatibility every release of the compiler. And there was a parallel weld with every compiler version. So every time you want to update your compiler, you have to wait for all the libraries to recompile and the library version was the library version plus the compiler version. You know, it was a big pain. Everybody was complaining. So we were like, okay, we have to have a very, very smooth compatibility story. So the attitude was, let's prototype everything, extensively test it internally at JetBrains, figure things out, and then throw out the prototype, rewrite the compiler in a good way, and release confidently. That prototype is Kotlin 1 point whatever, each 1 point anything is that prototype. Of course, as you probably know, when an engineer says they're writing a prototype and they will do everything nicely, it never happens. That prototype gets released. This is what happened to us, and this is why the compiler is very slow. And Kotlin 2, like K2, the new compiler, was started, I think, in 2019 or something, and will be released hopefully this year, maybe next. So this story got a little longer. We were serious about compatibility. And an illustration about this would be what I was busy with in 2015. It's my commits from late 2015, right before the release. All the commits, well, I left out other things, but like these are all about let's prohibit something in the language. Let's preventively say that this and that is not possible to do in Kotlin because we want to add features later. And interestingly, a lot of these features never made it into the language, but we were thinking about the async keyword. We were thinking about async blocks and async functions. We were thinking about something called sealed when, which is like a closed hierarchy enumerating expression. We're thinking about the yield keyword. So we were like when we were wrapping up the first release, we're trying to future-proof our design to be able to add features later. Because of course, adding a keyword after a release is a breaking compatibility. And only very few of these actually still make sense. The features are not done still, but these two, the prefixes for the numerals and strings, are still relevant. And this is from an actual design meeting. This is how we documented our design meetings. Go ahead. Yeah.
I think you made the right decision. C++, I draw the parallel with C++, and compatibility with C, and it's had compatibility for a long, long time.
Yeah.
And it built a community. The languages that don't do that don't build an community.
Well, I think it's a different kind of compatibility. So, the kind of compatibility C++ has with C for us is interoperability, which we were very serious about, and it was definitely a good thing. The compatibility I'm talking about is Kotlin 1.1 versus Kotlin 1.0. And that we could if we released in 2013.
Yeah, I'm talking about
Yeah.
that as well, because there was released C++. Right?
Yeah.
And they maintain compatibility, with their previous release.
Yeah, I understand. This is what most languages do. But what we more or less discovered during this process is you can be much more flexible with your compatibility story if you're nice to your users. So what we actually did in later milestones before 1.0, we broke syntactic compatibility, and we already had thousands of users, like about 10,000 users were actively working in Kotlin. And what we did, every time we released a new compiler, we also released a conversion tool that migrated all the code. And it turned out to be fairly comfortable. Like there were complaints, but it was okay. And also later, after 1.0, what we started saying, okay, we want to try out this design. So we mark it as experimental. We sprayed with warnings all over. So there's no way you're using it without knowing you're using it. You're using something experimental. And we reserve the right to break everything, and we actually do. I would deliberately add the word experimental to packages that this kind of feature will rely on. And then in the next release, we'll iterate the design and get feedback from early adopters, and then finalize it and already guarantee compatibility. And this is something other languages are copying from Kotlin now. So Java is doing that, and Java is actually progressing very fast, in part because they are now using experimental features and are talking to the community in this iterative way. So yeah, it's this is what we were busy with right before the release, outlining things like prefixes on strings and like sketching on the whiteboard what the future design will be. And this is still not a thing in Kotlin. It's been many years. Nobody got around to strings. We'll still have this on the backlog, but we can still add it without breaking compatibility because the right checks were in the compiler from the beginning. Any questions? Go ahead.
Big companies create languages and fail, like traditionally IBM, PL1, and Department of Defense with AIDA. So do you think Kotlin's can be anywhere near where it is today because of the Google?
Well, it's a good question. So my prognosis would be that by now, Kotlin would have something like 1 million users. So not 5 million. And it's a big question whether like what the curve would be from that point on. So there are two questions. So one question is how steep the curve would be. Like nothing like it was actually with Google. Like that was a huge boost in terms of how many people got to Kotlin per time unit. So that was definitely a game changer. There is another question of what markets are accessible. So Android is a huge market. There are millions of developers there, and server-side Java is a separate market. So two markets are better than one. Like how successful Kotlin would be without the brand of Google sort of endorsing it, I don't know. It's hard to tell. It seems like we were getting a lot of interest before Google came into play. So I'm not entirely sure, but it would definitely be less certain for even people unrelated to Android to make this decision of adopting Kotlin because it's credibility. So it's hard to tell. And I mean, there are quite popular languages made by nobodies, right? Like Ruby. Who even made Ruby? It's incredibly popular, right? So there are precedents for that. But it would definitely have been much harder without Google. More questions? How are we doing?
All the others, I have the question. All the other which is the easier for the all the other which is easy to develop on mobile.
We covered a lot of the things I wanted to talk about. I can talk a little bit about my personal experience. Yeah, so my background, as I mentioned, was in teaching before Kotlin. So I joined with some sort of like half academic, half teaching experience with a little bit of software development in my past. And then just did this for 10 years in Laravel. So coming from this background, it was kind of like I had to reevaluate a lot of things. And my initial reaction to let's make a new language was actually very negative. So the way it was like on my first day when I was invited over to JetBrains to talk about something regarding programming languages. And what I was actually thinking was they have some projects in domain-specific languages. So and my PhD is about domain-specific languages. So maybe it's something about collaborating on that. I was very interested. It turned out it's about a general purpose language and completely unrelated to that. I was like, why would you do that? Like you want a Java compatible language, there's Scala, it's great. And it was a very interesting conversation with a lot of new considerations coming into my world. So I was thinking about this kind of mathematical object and something I could use as an individual developer. And the arguments on the other side were, okay, but like now let's scale this to a huge code base and a big team over a long time. And let's think like how many people will actually master some intricacies of Scala, like implicits, for example, were very big. Like Scala did fix a little of that over time, but still. Like, and also it's very slow in big projects and compatibility is a problem. And we were trying to make tooling for this language for a while and it's goddamn impossible because language is so complicated. And I was like, oh, I never thought about that. Okay, maybe you're right. And we talked quite a bit about how one can make a language popular, because of course, like everybody creates a language like every day, and no languages get popular ever. So we were talking about JetBrains having this very good position with a lot of users, really loyal for their IDs. And it's actually magical. Like when I first came to conferences to speak about Kotlin, and I had like a JetBrains t-shirt on or something, people would come up to me and say, thank you for IntelliJ IDEA. I was like, oh, yeah, thank you very much. I have nothing to do with IntelliJ IDEA, but I'll pass it on. So, it was a really loyal user base. So we were talking about this, like, okay, it looks like it's possible to actually put it out in the market and people will be interested. And very quickly in this same conversation, we transitioned into, okay, so what should we put into LinkedIn? Like what's missing in Java, let's figure it out. And we had extension function, which is one of these like staple features of Kotlin, on the whiteboard that very day. And the syntax changed only a little since then. So it was like a very quick onboarding for me from this academic world into like industrial languages. It was pretty fun, actually. So I've already shown you this. And so I had to also transition from this kind of being, a coder with some programming languages background and figuring out mathematical problems, and then like writing compilers, into someone who manages not only developers, like we had marketing, we had like customer support, we had lots of people doing things like documentation writing, lots of things. And I had to figure out over the time, like, how do you actually deal with that? Like, is our marketing actually working well? Like, I need to hire those people. I need to promote those people. Like, are they actually doing a good job? How do I know if they do a good job? Yeah, it was quite interesting. Of course, like, again, my premise here was that I knew everything. And I took this whole thing with just common sense approach. Okay, this does seem good, this doesn't seem good. And over time, I just figured out that, okay, this is not how you do it. And I had to adapt a little bit. And later doing my my own company unrelated to programming, yeah, I just learned to ask people who actually know how to do things to, for advice and assistance and all that. That helps a lot. I really wish I started doing that maybe. Yeah, so as I mentioned, around here I stopped writing code. Like there are a few commits from me from this point on, and they are all in text files. And basically I think around this time, somewhere here, I realized that I just can't be the manager for the whole team anymore. And I had to change something, but everything was so focused on my decision-making, and I was involved in so many things that it took me about 2 and something years to actually be for it to be possible at all to me to step aside and let the team work. It was a very lengthy and unhealthy process. And I actually burnt out completely by the end of it. But it was a very good lesson. And now I know how to not only delegate, but also involve people in management and bring them over to the side where you think about the team as a whole and so on and so forth. That was interesting. And yeah, this is what I've just forgotten to change the slide. Yeah, so this was me in 2017 for sure. This is definitely me. And yeah, it was quite interesting. So at some point, I think it was early 2019, where I had to take a 4.5 month vacation to be able to do anything at work. The great thing is that my teammates just let me do it. And I remember this conversation with the CEO of the company. I was like, Max, I'm what was I? I was 35. Yeah, I'm 35, but it's I feel like I want to retire. What's wrong with me? He's like, take a vacation. But everything depends on me. I can't, you can go on vacation. It did work. Like I took this, I call it short sabbatical, and did recharge and then just came back and actually fixed a lot of the problems that needed fixing in the team. And also people without me, of course, they sorted out some things by themselves. You know, it was also a good thing for the team. But like my experience was that like a lot of the things that were more or less easy to tackle, folks just fixed by themselves. But the things where somebody needed to make a decision that's bad in some way and somebody will hate you for it, I had to do it myself. We have some, yeah. All right, I'll ignore it there, but we'll have it on the record. Do you want to, Justin?
Changing the subject slightly.
Yeah, okay.
Languages that kind of become bureaucratic eventually get
Mhm.
submitted to some sort of standards body.
Yeah, good
Is
question.
ISO,
Mhm.
do you see Kotlin eventually going down that route?
Okay, that's a very good question. So the question is, do we see Kotlin eventually submitted to a standardization body and standardized as a like whatever ISO or ECMA or something like that? So I don't think it's on the map at the moment. So the language design thing is pretty tricky in the sense of how you approach it. That there are many many trade-offs, many considerations. Yeah, go ahead.
I think it's more of a bureaucratic thing that people can tick and say it's an ISO standard.
I see. Yeah. So I don't think this is very big at the moment. Like we didn't get very many requests like this. Maybe because we don't target low level.
Do you think being open source makes a difference?
I don't know. So my understanding is a lot of people care about certification for some technology, like aerospace would care about a lot of certification. Kotlin's not really applicable there, so they don't care. Like I think Rust would need something like that. I'm not sure would anybody care about something like an ISO standardization now. It used to be a big thing in the 90s, for example, because it felt like, at the time, I think, it felt like if there is a standard, anybody can implement that. And everybody knows that it's not the case. Like now it's not how you actually do language anyway. So we didn't have any pressure from any customers, like bigger companies, smaller companies, nobody ever cared about that. But what people do care about is the language being more or less in the open. So people want a good license, and we have Apache 2. And also, since we partner with Google, who cares about their users quite a bit, we have this what's called Kotlin Language Committee, which is 3 people, 1 person from Google, 1 person from JetBrains, and 1 independent person. And this committee has power only over compatibility issues, like over incompatible changes. If we want to fix a bug that makes some code work differently, or that introduces a new error where previously there was no error, that should go through the language committee. It's usually some very small things. And then there are just regular meetings. Okay, so we found these bugs. They technically introduce new errors. Some code will break. What do we do about it? Like how we deprecate this thing, warn people, how we inform everybody. No, so this is something that requires approval from this body, but it's a very, very small body. It's nothing like the C++ design committee or anything like that.
I have a question from the floor. Remote user has asked, which is the easier programming language for Android development, Java or Kotlin?
Okay, so not being an Android developer myself, I can only speculate. So I would say that if you want to get productive on Android quicker, you should pick Kotlin, because you will have all the nice things. You will have Jetpack Compose. You will have all the new and shiny technology available to you. And like, I think this is what is recommended now, and this is what a lot of people do. I think there's very little reason to start on Android with Java. But if somebody is already on Java on Android, there will be a very complicated decision-making process around that. A lot of companies switched and are happy. I don't actually know about an Android targeting company that switched back from Kotlin to Java. Some server-side companies did, very few, but still. But I didn't ever hear about an Android company do that. More questions?
Just contribution here, perhaps. I was involved in a very large project on which your friend of mine, David Denton, was also a developer.
Yeah.
And what we found working very well was that he held kind of weekly masterclasses, little katas, in which he'd say, "This is the problem. What are we going to develop around this and introduce some feature?" And that meant the whole team was being brought along and developing more expertise and using the specific features of Kotlin, which make it distinct from Java.
Yeah, I think David did a lot of this kind of work for your community as well. I'm very grateful for that. Yeah, it's a very interesting dynamic of how Kotlin gets adopted normally. It's an interesting thing. So a language that, especially before it was attached to a platform, it was the only way to adopt Kotlin was basically bottom up, when some people on the team would like to write Kotlin, and they would either just add it to the project and start writing tests in it, or just showcase their great experiments from a side project or something. And this is how it usually works. So, and it was our strategy all along to enable this very gradual adding of the language. Like you add a few lines of configuration, and okay, you can throw in one Kotlin file.
And the testing is a really important thing.
It is.
It's much easier to get
Yes.
to agree.
Yeah, it's much easier to sell, of course, because who cares about tests, right? Yeah, and it was quite interesting. Like for most companies, it's not a problem at all to have something like tests written in a different language. It's a completely different story in a big company. For example, I think it took Google about 3 years to actually allow Kotlin across the organization, because they have so much internal infrastructure. And we were closely working with people who recreated all the infrastructure for Kotlin. And they have a lot for Java. It's a huge thing. And the Android division switched very quickly, because they target different environments and they don't really care. But Google at large, they had to wait for all this tooling internally to be released. It was a fairly similar thing with Facebook and other big companies, where very early on, we had conversations like, okay, so this language looks very, very interesting. So how do we scale this build system to 500 build machines? Huh? I've never seen 500 build machines. Let's talk about it. I don't know. Let's figure it out. It was it was also very surprising how big some code bases for mobile apps are. One of the major apps we're talking to had 50 million lines of Java, or 60 million, I don't remember. But I was wait, I'm using this app. How come it's so big? Yeah, so it's very different on different scales. So for a smaller team, for tests, it's very easy to introduce. And then, this is how it works. It gets people hooked up on the productivity side of it. And this is why they want to go through the trouble of adopting it. There was also an interesting case from another fairly big company working on the server side. What they did, they had a big legacy system, like a very popular product with a lot of Java in it. It was a monolithic server-side product. And they wanted to basically to energize people, to motivate people to refactor the whole thing, to make it much more maintainable, so on and so forth. And what they did is they said, okay, we're starting this new and shiny architecture over here on the side in Kotlin. And if you want the nice productive environment and clean architecture and all that, please come over to the Kotlin side and redo everything the right way. And it also, across the industry, it's often a pretext for hiring more in-demand developers, attracting people to your company because we are using this shiny hip technology and you will have a lot of fun here, which is true. You will have a lot of fun. So yeah, but people actually use this kind of sort of modern appeal of Kotlin as a strategy for attracting people to projects or to companies. Yeah, it definitely works like that. Okay, more questions? Go ahead.
As you're such a large span of time, how did you and your team, from going from such a small team to a large team, what kind of processes did you have in place to ensure the vision was?
Okay.
Or did it at any point where did things change? How did you decide?
Okay, so let me answer the first part. So the question is, what kind of processes did we have in place to make sure the vision stays in place with the team growing and everything? I think it was just micromanagement helped for a long time. Everything went through me, and I had a pretty clear picture. Of course, if you think about something full time for years, I have a very clear picture of what you're doing. And this was part of the thing. So I was talking to every developer very often and about the technical side of things, like how we do things, about what we're doing, so on and so forth. And also I think a lot of people on the team were very absorbed in their coding things, and the decisions on the design side, on language design side, and on the strategy side, a lot of people just didn't think about that. And our job was to communicate what kind of technical things we want to do clearly enough for smart people to figure it out. And so it didn't require a lot of processes back then. But of course, when we scaled up to 100 people, it became much more difficult. What helps is that the team is very heterogeneous in the sense that people do their different subsystems. So there is an IDE team, for example, and a compiler team, the libraries team, and a lot of other teams with their different targets. And these tools they interact, but they're fairly separate. Each of them is supposed to be working on its own. So they have interfaces, but they have a fairly clear idea of how a build tool works, for example, or how a library should be presented to a user, so on and so forth. So that helps. But in general, yeah, after a while, we separated the product management function from just leadership. And we have a team of product managers who talk to the users, who prioritize things, who communicate this to the development team, and they own the backlog. So this is one of the processes that actually helps. It's that the central prioritization for high-level backlog. And then of course, we involved quite a lot more people into all kinds of management decisions. Talking to more people, we do some a few days of just strategy thinking inside the team. I don't know if it's still going on now, but we used to do things similar to this. So, it was kind of a lot of experimentation in terms of involving more people into thinking about the thing at large. It was a tough process. It would have been much easier if we started doing that before we grew to a bigger team, but yeah, I didn't know. Another question, go ahead.
So, do you envisage that something else would ever write a full Kotlin compiler?
Good question. Would anyone else ever write another Kotlin compiler? I'm trying to think of a reason for them to do that. I don't think, I think one possible reason would be if Kotlin gets adopted as a primarily native language, compiling to native codes. Because currently we have a compiler, the Kotlin native compiler, which itself to run requires the Java solution. And it makes it, Java is actually a pretty fast thing to run a big code base, but still it's a slow startup time. There are downsides to it. So I can imagine if somebody really, really wants a fast Kotlin compiler for native development, they could do something like that.
I once predicted that nobody would write a successor to GCC.
Right.
When Apple were supporting LLVM, I wrote a blog post saying from the failure. And of course, I was completely wrong. The reason I was wrong was licensing.
Mhm.
The LLM is under a MIT license, so Apple can put proprietary extensions. So
Yeah.
at some future time, they can add instruction, they don't have to release the code. Because you know,
Right.
someone might be interested for the same reason. Actually, an open source license, or the kind of open source license you use, might not be compatible with some organizations' longer term interests.
That's an interesting point. So I'm not entirely sure. We're using Apache 2, which is very free. It has very little over MIT. So I think also proprietary extensions. I mean, if you wanted to distribute a proprietary extension to Kotlin without opening its source code, it's definitely not a problem, because you can, like, you're allowed even to embed Kotlin into a closed source product. Like, this license allows that. I'm not sure if even Apple will benefit much from owning their own compatible version of C++. They don't care, really. But like, yeah, well, when you're betting against people like Chris Ladner, usually doesn't work.
Well, I don't think that wasn't his rationale.
No, he wasn't. Yeah, of course. More questions. All right. Okay, so I have a few more slides, but I don't think it's.
I'd be interested in hearing about the new ventures.
New ventures. Okay, so yeah, I had something like this in the beginning. Yeah. So what I'm doing now? So basically, after my whole burnout story, by 2020, I was like thoroughly sick and had to. So I didn't only hate my job. I actually had some health issues already, so I had to take a break from all kinds of work. So part of the reason was I was overloaded with work. Another reason was I started another company unrelated to Kotlin in 2017. And I don't recommend doing two projects, although my time was formally separated. Like, I did 1 day of this company and 4 days of Kotlin a week. So it was formally within 40 work hours a week. But it means you have double the amount of problems. You have your problems in Kotlin, you have your problems in this other company, and they're all yours, although you're spending only 1 day on that company and 4 days of Kotlin. So very unhealthy decision to make. Never do this. I'm pretty happy with this company. We're currently selling it, but it's been a very, very good journey, and we actually brought 75,000 people to therapy, which is great. But it was a very unhealthy decision from a mental health standpoint to start this mental health company while I was doing another project. So yeah, I'm now not really involved with management of the company. We've hired a C-level, and people are working there, doing a very good job, and they're happy with that, and the company is being sold. And currently my I'm in this kind of taking a break from everything finally state where I'm mentoring people. I'm like coaching tech leaders and doing occasional projects. I do like some side projects like community events and things like that. And I'm currently thinking about starting a new, bigger thing. It seems like my sort of attention span is about 10-ish years. So I did like about 10 years of teaching, about 10 years of Kotlin, and then this transition period. And now I'm probably starting another 10-year or yeah, maybe longer projects, thinking about simulating social processes. And that's actually in terms of the problem setting is very similar to Kotlin. It's something that may well not work at all. But even if it doesn't, I'll learn a lot in the process. So I'm willing to do that. Feel free to ask questions about it or about something else. Go ahead. All right. Yeah. So imagine any social system like a university or like a tax office or any kind of institution. What we can do now, we can study them the way they work by talking to people, And we can theorize about them usually with some sort of formulae modeling, this kind of thing. It's done in economics a lot, a little bit in other areas. But the kind of modeling we do there with mathematical formulae is incredibly imprecise. So what we have for economics kind of works a little bit, but not very much, because the formulae are very, very short. And the economy is very, very complicated. So the idea here is to try to come from a different angle. So how people try to model, for example, the economy now is by numerical simulation. When you have like very small descriptions for some processes like production, for example, or taxation or something else. And what I want to look at is try to model the actual agents, like every individual accountant in London and every individual tax inspector, and how they interact to create the process called taxation. And with modern AI, so my back of the napkin calculations show that we are kind of on the brink of being able to compute this feasibly. So hopefully we'll be able to do something like this. And there's at least one group in the world doing something similar. They are modeling every citizen of Austria with a very simple non-AI model, like very simple thing. And they get fairly relevant results in terms of the economy of Austria. They derive some like sensible computations from that, from like 8 million agents simulated for the entire country. So I would like to do something like that on a smaller scale, but with a more precise model for each agent.
So you're not going to say like system dynamics?
System dynamics, one of the things that could be applicable here. It's a huge thing. Basically nobody does that. So it's a completely new thing. I'll need to talk to a lot of people who know more about this than I do.
We have a few questions from the floor.
Great.
One was more of an observation from David. It says, if Snowden would have things to say about these simulations.
Oh, absolutely.
He said, I remember hearing him saying people are not ants.
I'm pretty sure they aren't. I've seen some people, they don't look like ants. Yeah. So I think I understand the sentiment of trying to predict things about humans has this kind of sinister, dark appeal.
I've read Foundation to Religion by Isaac Asimov, written in the 1930s.
Yeah, well, yes. And I agree, predicting things about humans can be also dangerous. And we'll need to deal with that. But also, I think not being able to predict things about humans is dangerous. So yeah, I understand there is a big question there. I'm aware of that. Thanks for mentioning it.
Another question from somebody who says that they're an intermediate Android developer, saying,
Okay.
can the Kotlin language, can you use the Kotlin language to develop in Android 14 for the future? And can Kotlin support Scala? I don't understand the question.
Ooh, okay. So the Scala thing, I'll have to define some details about the question. So if we're talking about interoperability in terms of Kotlin calling into a Scala library, then yes. In the sense that Kotlin sees Scala code as Java code, and a lot of Scala libraries are callable through the common Java interface. The interface you're getting there will be much, much less rich than Scala itself, because Scala has a very, very rich type system that's not represented in the Java interface at all. So technically, yes, it won't be as nice as calling Scala from Scala. It will be as nice as calling Scala from Java. Speaking of Android 14, I'm not sure what we're talking about. So Android is a pretty complicated ecosystem. The operating system is definitely not written in anything like Kotlin. It's written in a systems language. So that is not relevant here. So the operating system and the virtual machine will all be written in something like C or C++. I think it's C++ actually. I don't know if they're using Rust, but they probably will, since the Linux kernel already is using Rust. So probably Android will over time because they're using the kernel. So yeah, there Kotlin is just irrelevant. For libraries, I think a lot of newer libraries are being written in Kotlin. So all the like everything connected to Jetpack Compose can be written only in Kotlin, basically, if you want to use the Compose's mechanism for updates of the UI. There's no way you're not using Kotlin. It's basically, as far as I understand, it's basically not available in Java. I don't remember if Android now has the policy in place of actually writing all new libraries in Kotlin, but I think the word talks about this at some point. Oh, go ahead. All right. It's actually on my list of things.
That has to be the last question because the impressions of
All right. Yeah. So basically, this is where it comes from. This is my home city, and this is the office where we worked in Kotlin initially. And this is the island called Kotlin. The reasoning was Java is an island with coffee, and there was another competing language, Ceylon, which was an island with tea, and we had an island which we could basically see out of the window. So we called the language that.
there's a tower, isn't there?
Is there a tower? Oh, on the Kotlin Island, there is. It's a military base, like a Navy base.
There's tradition for languages being named after towers as well.
Oh, yes.
Like
Yes. Yeah, so this is the town of Kronstadt, which is on the Kotlin Island. What they have is basically a Navy base and a huge cathedral in the center. And there is a lighthouse, of course, because it's out at sea. But I don't have a picture for that. Yeah, so this thing in the Western classification is called Kotlin class destroyer. It's a Soviet ship type of ship, and we in our early releases, when you Googled Kotlin early on, this is what came up. Yeah, and we actually added a disclaimer that the language is not meant for class destruction in any way. And interestingly, this thing is called Haskell, and I think it may be a British ship, actually, British class of ships, or American, I don't remember. And this is Scala. And this is Reno Scala. So yeah, we had those jokes going around early on. Also, yeah, you can't come up with a name for a language, which is not a bad word in some language. We actually tried for a while, and there's no way. So, in this case, German doesn't like this, but the actual Germans that use Kotlin don't mind. Also, Kotlin is a ketchup. It is a place in Poland, and they make ketchup. And once in a while, I get a present like this from people from Poland. Yeah, so the naming thing is very complicated. It's one of the things I hate the most. Thank you for your question.